Hey guys, I'm JSer, who is not good at algorithms. Today I'm making this video to prepare my interview in next month from Facebook, so hope you can stay with me. And in this video I'm going to take a look at 953, verify alien dictionary is marked as easy. We're given an alien language word and they use the same English letters but in a different order. We're given an order also. A sequence of words written in alien language and the order return true if and only if true are sorted lexicographically in this alien language. For hello, LeetCode, you see H is before L in this order, so it's true. And this is false because the top three word character is the same, but D is bigger than L, so this is false. For Apple, well, the top three character match, but the first one should be smaller than the next one, so this is also false. Well, there's nothing trick here. We just follow the requirements and do what we are told to. So I'll create it by just for let the input, the words, there's no empty list and no empty word. So we're just comparing the words to the previous one. So we start with 1. If compare words I minus 1, okay? A word I. Is bigger than 0. I mean, if it is not sorted. So if that's the case, we return false. Then we return true, right? Now we need to implement this compare word method. To compare this is simple. We just traverse through all the characters and compare one by one. Now, how can we compare these two characters? So we'll create a new method, compare a digit to character. Character. If it's bigger than 0, if it's bigger than 0, we return 1. For the other case, we return minus 1, right? We only continue when the letters are the same. And finally, we will check if I has extra, if the first one has extra characters, which means I is not equal to a.length, then we return one. And if I if I equals to a, the last one, we say it must be no. I'll say if it is not. Oh, it's the same. Huh? If I is equal to length, it means, well, it's just different. It might be the same, right? If A is equivalence, and if we will return J, if just add the length, then it should be 0. For the other case, it is minus 1. For the other cases, we return bigger. It's irregular case. It's invalid cases, right? And how we compare character? We need to create another method, const a to b. Well, this is simple. We just compare the index of this A and B. So in order to do that, we need to create a dictionary new map. We just store a map with the character and its index. And then in the compare function, we just return dict get A, dict get B. Right? I think it should work. Just let's run the code. Yeah, let's try submit. Wrong answer. What? Obviously we fail at this. Okay. So what's the problem now? Compare world. It should be -1. Okay, and the row word, it should be W R. Okay, O R R and W. A B C D E F G H A M P Q P S T U V. There's no R. Oh, R here. R W. R bigger than it, so it's false. Why it's bigger than 0? Man. I think there's some problem with the ending condition, right? Console log failed at we failed at word. Oh, we didn't fail? What? Let's log the input, log the output. So world is small, row is small. That's weird. Something wrong here? Seems no problem. Oh, this should be BJ. My God. Still failing. Well, actually, it's 2:30 in the morning. My brain doesn't work very well. Okay. Anyway, I'll log down AI and BJ. We can compare WW. Ah. Oh my God. Yeah. We continue only when they are equal to 0. So the compared equals this. If smaller than 0. Cool. Let's submit. Oh, we are so slow. Only faster than 8%. How could we improve? Well, let's try. The first thing is that we were comparing these two. Is there a way we can just get a real value of these two? hash it like if word, it means 1. Second one is this. Third one is this. If we create a 26 spaced, yeah, I think we could, right? This one should be smaller than it. Sure, it's smaller. And yeah, we can hash it into some number, but how? Well, if it's if it is length is different, we could take the shorter one, right? Like this, and do the compare. If it is bigger than the first one, we took shorter. The length would be, each one would be 20. If that's the case, actually we can say we make it a fixed length and calculated by direct hash, right? Cool. So the input, so the length will be maximum 20, and all the input are based on English letters. So this reminds us with the simpler solution. Let's try to do that. Okay, the idea is simple. We will just for the word, we will first hash them. Zero. We hashed and keep track of the previous one. It's okay. So we use previous. Prev equals 0. And then we start 0 if hashed. Okay, we hash the current. 1. Hashed equals hash. Words I. We hashed it. And if hashed. Hashed should be bigger than it. So if it is smaller, bigger or equal to it. So if it's smaller than prev, return false. Of course, don't forget to update the hashed. Prev hashed. So now we need to implement this hash method. Strat. There is this. The dict is needed. And so how can we hash it? Well, we treat the hash. Hash is based on 20 digits, 26 based number. So the index will start from 0, and this will be 25, right? If it's 0, it will be 0. So let's just use set it to 1, so base 1. Okay, so it would be what? It would be if 26 based 20? Wow, that's a big number, right? How could we do that? 26 base? Isn't it too big? Twenty-six, 20, right? Wow, it's super big. It's not possible. There's big int, right? We could use big int. I'm not sure I'm able to use it, but is there any other way? 20? How can we hash it? Maybe we could. Wow, it is too big. I think maybe there is another way. We cannot use number. Okay, we just use a string, right? With the because okay, in string we use pad. Okay. Okay, so the const segments will be empty. We will let I equals I 20 sex push. We push what? We push dict str I, which is the number, right? Const index would be like this, and then we'll push if this is a index is smaller than 10 and 0 plus index, or the other case we just index, and return sex join empty. This should pref is not defined. Pref? Oh, there's no pref. This is not 0 but empty. Sign. Oh shit. Should be let. God, mamma mia. Console log hashed. Nothing. Yeah, with sex push. Empty. Why? Okay, we hash str and the segment index. Undefined. Why undefined, man? Word, world, row. Astra, shit. Huh? No, 20. This is right. Astra, yeah, this is also right. Console log index. Undefined. God. We're using set map here. So you see the hashed would be 01, 01, 03, 05. This will be undefined. Get undefined will be undefined, right? So index this false, so it's undefined. I think we should actually stop using 20 but use str.net. Yeah, that's a map. This is accepted, but it's still slow than everything. Well, I think it reminds me that we actually could do some translation, just changing them into the real world string and do the comparison. So actually for word, in a real, if we translate like this, it would be A, B, C, D, right? So that if that, we could use a native implementation, right? Okay, so there's another solution. Let's try to, there is a translate prev, we create a word of translate. If translated smaller than prev, then return false. Prev equals translated. And then we need to create the translate word. Translate string. Okay, and now we need to, we need to oh, actually this doesn't change anything. It's the same as the index, right? Anyway, const real order B C D E F G H I J K L M P Q R S T U V W X Y Z. Real order index. Run the code. We translate it. What's the translate? Const translate. We translate to BCDF REB R. Oh God, it should be. There's this. Oh, cool. Well, finally, we have improved this, but I don't see why. Oh, if we remove the console? I think it's much better than the previous solutions. Yeah, I think maybe because we're using the native comparison of string rather than doing by ourselves. Anyway, this is let's try to see what the other people's are or what they are doing. Wow, this is very simple. Loop 1, loop word, loop 2 for each word, console log words. Index is wow, this is very brute force, right? This could be so fast? Really? The index of actually costs a lot of time, right? Anyway, this I don't think actually this would be a great solution. Actually, I think in a real whiteboard test, if we did something like this, if we have the let's try to analyze the time complexity. We forgot to do this. For this one, this is linear time. This is cool. And for this one will be n word, right? Word length, and this will be n word. So actually, this will be let's say n times n. N is average word length. For this one, we hashed it, but actually we still traverse through all the digit, right? Time complexity doesn't change. Except that you see for here, we traverse 2 times to compare. But now we only traverse once because we only get the hash. So we actually improved it by half the time, but complexity doesn't change. This is also for this n, a hash, so it's still nm. For third one, of course, it's the same. Yeah, so that's all for this problem. I don't know if it helps, but hope it helps. Okay. See you next time. Bye-bye.